Hi dear students and viewers, welcome back to our channel. Dear students, in this video we are going to discuss about some important problems regarding the screw gauge and what is the least count of screw gauge and how we can find out the diameter of the given instrument by using screw gauge. And among the vernier calipers and screw gauge, which one has more accuracy, and is there any error in the screw gauge, how we can find out it, and how many types of errors in screw gauge and how they can be rectified or corrected. Let's see in this video. Watch the video till the end. In the end of the video, we have to discuss about the remaining problems which are given in the previous examinations. That's why watch very carefully. Dear students, what we discussed in previous video, vernier calipers. What is the least count of vernier calipers? Least count of vernier calipers is 0.01 centimeters. 0.01 centimeters. That is the least count of the vernier calipers. And in case of screw gauge, its value is 0.01 millimeters. If you can convert it, that should be 0.01 centimeters. Clear? This is for what? Vernier calipers, and this is for what? Screw gauge. That's why we can measure the diameter of the given instrument by using screw gauge very accurately. Clear? So now coming to the point. What is the screw gauge working principle? The screw gauge working principle is nothing but screw in a nut. Screw in a nut. That should be also said like this. It works on the principle of micrometer screw. Micrometer screw. In screw gauge, accurately cut single screws or single thread screw that should be rotated in a nut, closely packed nut. Okay, and here the screw gauge should be like this. Here this one is, here it is A and this one is B. We are saying now A and B are called here studs. A and B are the studs, and in that A is the fixed. A is the fixed, and now this is the B here. It is a stud now. When we can completely open it, that should be here. Clear now? So this A is the fixed and B is the, can be movable. These two studs are fitted over a metal frame. This is the metal frame that should be in the shape of U. Clear? And these are the screws. These are the threads. And now here what you are finding, this is very important, you have to remember. So this is the one horizontal scale, it is there, that should be commonly called as pitch scale or linear scale. Pitch scale or linear scale. And this horizontal line is called as the index line. What is the horizontal line? Index line. On that index line, some divisions are there. One division is equals to there 1 millimeter. 1 millimeter. In a screw gauge, there is one horizontal scale, it is there, that should be commonly called as pitch scale or linear scale. On that linear scale, every division should be taken as the 1 millimeter. Clear? And now here, this is the one circular scale or head scale, it is there. This is the circular scale that is commonly consists of here 100 divisions. 100 divisions. Clear? This is the pitch scale and this is the head scale. Clear? So this is simply the description and the structure of the screw gauge. And now how we can find out the least count of the screw gauge. How we can find out the least count of the screw gauge. The formula is least count is equals to pitch of the screw. Pitch of the screw by number of head scale divisions. Number of head scale divisions. Clear? So this is the formula for least count. What is meant by least count? Least count is nothing but the least value that can be measured by using that instrument is what we call least count. Here the least count should be measured by using this formula, pitch of the screw by number of head scale divisions. And now here again there is some formula for pitch of the screw. Pitch of the screw is equals to distance moved. Distance moved. So this thread is there, that should be moved some distance. The distance moved by number of rotations. Number of rotations. Here pitch of the screw is what? Distance moved by the number of rotations. Number of rotations. Here pitch of the screw. Here what is distance moved by the number of rotations. Number of rotations. To do that one, simply first we have to move the, here there is some knob, it is there. By using that, one knob is attached to the circular scale. By using that, we have to make that B should be moves towards the A, until both will reaches the A and B. Both will reaches the A and B. And after that, you have to find the how much distance traveled. How many distance traveled by the, here when both are closed, when A and B both are comes contact, then we are not finding any line on the pitch scale. Dear students, when both studs are made to comes in contact, then we are not finding any line on the linear scale. After that, you have to move this head scale by one rotation. Then you have to find out the how many lines we are finding on the linear scale. To find out the least count, first we have to find out the pitch of the screw. We have to find out the pitch of the screw. What is pitch of the screw? Distance moved by number of rotations. By using this knob, we have to make A and B, both studs must be comes into the contact. When they comes into the contact, we are not finding any line on the linear scale. Then you have to make the rotation slowly. For one rotation, how much distance should be traveled? You have to find out it. So generally, in a screw gauge, the head scale must be moved 1 millimeter for one rotation. 1 millimeter for one rotation. That's why here distance moved is equals to what? 1 millimeter. And number of rotations are 1 rotation. Or you can take 5 rotations, then it will travels the 5 millimeters. Then what it is equals to 1 millimeter. That's why pitch of screw is what? 1 millimeter in a screw gauge. Dear students, in screw gauge, for one rotation, the screw should be crosses the two threads. In a nut, for every rotation, the screw can passes the two threads. Okay, that is what here. Think about pitch of the screw. That is what? 1 millimeter. So already we discussed pitch of the screw is what? 1 millimeter. And now here, how many head scale divisions are there? Here nearly 100 are there. Then what do you get here? 1 millimeter by 100. That means what? 0.01 millimeters. This is the least count of a screw gauge. If you can convert into the centimeters, we will write 0.001 centimeters. That's why here we have to say that or said that it is more accurate than the vernier calipers. Vernier calipers we will find only for 0.01 centimeter only by using vernier calipers, but in this case 0.001 centimeters. Clear? So now we discuss about the how we can find out the diameter by using this screw gauge. What is the formula and how we can do that one? Let's discuss. Here diameter formula. That is here diameter is equals to MSR. It is also called as PSR, pitch scale reading, plus here what it is HSR, head scale reading, into LC. This is the formula we are going to use. If there is any error, we have to write here MSR or PSR plus HSR into LC plus or minus error. Plus or minus error. We have to S like this. So this is the formula we are going to use to find out the diameter in case of a screw gauge. So before going to measure the diameter, first we have to check whether that screw gauge has any error or not. So how we can find out whether the instrument has error or not? Simply there we have to say that here, to measure the diameter, first we have to check whether that particular screw gauge has an error or not. How? Simply here we have in the options of object between the two studs, we have to rotate the knob until both studs will be comes into the contact. A and B will comes into the contact. On that time you have to check, this is what index line of the pitch scale. Pitch scale it is there, it is also called as linear scale. Okay, this is what index line of the pitch scale must be coincide with the 0 of the head scale. What is 0 division of the head scale? Clear? This is the linear scale and that should be what is index line, and this is what 0 division of the head scale. 0 division of the head scale. When both studs must be comes in contact, then we have to check, is there any error? 0 error. How we can check it? When both studs comes into the contact, then we have to check, is there any coincidence between the index line of the linear scale and 0 division of the head scale. When both should be coincide like this, then there is no error. 0 error is not available. Then if there is no coincidence between them, no problem at all. What is linear scale, index line and 0 of the head scale, when both must be coincide, then there is no problem, there is no error. If both are not coincide, then how we can identify the error and how it can be corrected? Let's see. When both studs are comes in contact, we have to check whether the index line or reference line, index line and 0 division of the head scale, both are coincide or not. If they are coincide, there is no error. If there is no coincidence, then there is some error. And there are two type of errors in the screw gauge. One is positive error and one is negative error. Look here, in this diagram you can observe, when both studs comes in contact, A and B comes in contact, after we checked, there is no coincidence, and you can observe here, this is what here, this is the index line or reference line, index line. You can observe here, this 0 is above the index line, 0 is the above the index line, or 0 is exceeds the index line, 0 is above the index line, 0 is above the index line, then that error is called negative 0 error, negative 0 error. Clear? So for example here 0 and 95, that means what? Almost all here the magnitude is 5, magnitude is 5. That's what I have to say here, error is equals to -5 and correction is positive, correction is +5. So if the 0 is exceeds the index line, then the error is what I have to say, negative 0 error. And how we can decide the magnitude? The number of lines which are exist between the particular 0 and next division. Here 95 is there, 0 is there. Then obviously here this one is 100 and this is 95. The what it is? 5 error. The error is what? -5 and correction is +5. In the same manner, look here. In this diagram, 0 is below. 0 is below the index line. Below the index line. Then what you have to say? This is positive 0 error. Positive 0 error. Again, how much difference? 5. That's why here the error is +5. Error is the +5 and its correction is negative. Its correction is negative. minus 5. So for example here, we will discuss in the problems, no problem, don't worry about that, corrections. Simply here, for example, D is equals to what? MSR plus MSR or PSR? MSR or PSR. And again, what is head scale reading into LC? Here is what is error. Error is plus or minus. We have to write 0 error. Plus or minus we can take. And now here, how we can find out the PSR and how we can find out the, for example here, I am saying now it is the A and now it is the B. Here, this is the B index. And now here, we kept some one object should be like this. Okay, you can draw here, no problem. This is the stud B and this is the stud A. We are inserted the object in between the two studs, Then here, how we can find out the PSR and how we can take the HSR. That's the point here. After inserting the object between two studs, how many lines we are finding? How many lines we are finding on the pitch scale that should be taken as PSR or MSR. How many lines we are finding on the index line after inserting the object between two studs, that should be taken as here PSR. And the division which can be coincide, for example, I am saying it is now 20. Just imagine the 20th line is exactly coincide with the index line. The 20 should be taken as here HSR, head scale reading. Clear? Head scale reading. Now here I am going to write here what is MSR. For example, we are finding now here 6. We are saying some 6 lines we are finding after inserting the object. Then here what is PSR or MSR? That is 6. And which is coincided here? 20. So HSR is what? 20. Then the example, if you can take error is minus 5, correction is what? Plus 5. That's why here 20 plus 5. And now what is HSR is what? 25. Again, formula is what? MSR plus HSR into LC. What is MSR here? 6. 6 plus 25 into LC is what? LC is 0.01. Then what you get here? 6 plus 0.25. Then what you get here? 6.25 millimeters. So in this way we will find out the diameter. After inserting the object between two studs, how many lines are we are finding on the pitch scale? That should be taken as pitch scale reading or MSR. And after that, what is the, how we can take the HSR? Simply we can take the division which can be coincide with the index line after inserting the object between two studs. That should be taken as HSR. After inserting the object in between these two, we are estimating that 20th line is coincide with the pitch scale or index line. Then that should be taken here HSR. So already, for example, the instrument has negative error. Then what you have to say? We have to do the correction 20 plus 5. That is what? 25. And now here 6 plus 25 into 0.01, and that should be what you get here 6.25, like that. For example, if the instrument has positive error, then the correction is what here? Minus 5. Correction is minus 5. In the same example, what is here? Simply MSR is 6 and HSR is what? 20. And the error is what? Plus 5. Then what you do? Correction is minus 5. That is what? 15. Then simply what how we can write? PSR plus 6 plus 15 into 0.01. Then what is here? 6 plus 0.15. That is what? 6.15 millimeters. That is the diameter of the given instrument or given rod or anything, whatever may be. So in this way we will find out the diameter. Now let's see some examples which are given in the exams, competitive exams. Let's see one previous problem which was given in JEE Mains 2006. JEE Mains 2006. Let's see the problem. The circular scale of a screw gauge has 50 divisions and pitch of 0.5 millimeters. Find the diameter of the sphere. Find the diameter of the sphere, and main scale reading is 2. The circular scale of a screw gauge has 50 divisions and pitch of 0.5 millimeters. Find the diameter of the sphere. Main scale reading is 2. And he was given some diagram. In that you have to observe, this is the pitch scale reading, PSR. It is also called as main scale. Clear? And in the diagram it was mentioned head scale divisions. Head scale divisions, what it is? 25. 25. So what you have to find out? We have to find out the diameter of the sphere. This is the sphere and that should be in between two studs. So we have to find out the diameter, and he was given 4 options. First option is 1.2 millimeters, 1.25 millimeters, 2.20 millimeters, 2.25 millimeters. So all of you know diameter formula is what we discussed. Diameter is equals to PSR. It is also called as MSR plus so CHSR or HSR into LC. HSR into LC. Clear? So now here he was given PSR is what? 2. PSR was given 2. And he was given pitch. What is pitch here? Pitch of the screw gauge. Pitch of the screw gauge. He was given how much? 0.5 millimeters. 0.5 millimeters. And we have formula is least count is equals to pitch of the screw by number of head scale divisions. Number of head scale divisions. Pitch of the screw is what he was given? 0.5. 0.5 by, and number of head scale divisions. How many there here? 50. That means what simply here? So 0.05 by 5, that is equals what? 0.01 millimeters. Clear? And what is the formula here? Diameter D is equals to what? PSR. PSR value is what? 2. So here he was given 4 lines are 2 millimeters. In this one he was given 4 lines are 2 millimeters. Then each division is what? Each division what? Here 0.5 millimeters. Got it? In this diagram he was given 4 lines are the as 2 millimeters. It means that what? Each division what? 0.5 millimeters. 0.5 millimeters. That's why here PSR or it is what? 2 into 0.5. 2 into 0.5 plus HSR how much given? 25. 25 into LC. LC value is what? What do you got? 0.01. 0.01 we got. D is equals to 2 into 0.5 means what? 1.0 plus 25 into 0.01 means what? 0.25. Then D is equals to what? 1.25. So D is equals to what? 1.25 millimeters. So this is the diameter of the sphere. Now here among the 4 options, second option is the correct one. See the next problem. It was given in NEET 2020. A screw gauge has least count of 0.01 millimeters and there are 50 divisions in its circular scale. The pitch of the screw gauge is, the screw gauge has least count how much? 0.01 millimeters and there are 50 divisions on its circular scale. The pitch of the screw gauge is, options are given 0.25 millimeters, 0.5 millimeters and 1.0 millimeters and 0.01 millimeters. So dear students, we have know about the least count of the screw gauge. What it is? Pitch of the screw. Pitch of the screw for number of head scale divisions. Number of head scale divisions. Number of head scale divisions. So what he was given? He was given least count. How much it is? 0.01 millimeters given, and pitch of the screw is we have to measure, and divisions how many? 50. Therefore 0.01 into pitch 0.01 is equals to pitch by number of head scale divisions how many? Here 50. Therefore pitch of the screw is equals to 0.01 into 50. Then what do you get? 0.01. 1 into 50 means 50. 0.50. That means what? 0.5 millimeters. That's why second option is the right one.